Solve the equation log base 2 of x plus log base 2 of x minus 3 equals 2. This is a logarithmic equation because it involves log of an unknown. To solve this log equation, we cannot rewrite it using the exponential form yet because there are two terms with log, and so we need to find a way to combine them. Both of the logarithmic terms are on the left-hand side, and they are being added with the same base. We can rewrite it using the law of logarithm. The sum of log is the log, the same base, of the product of the arguments of logs. In this case, x times x minus 3, and the right-hand side is 2. Now we have a simple log expression. We can rewrite it in exponential form. The base is 2, so we take the base 2, we raise it to the other side, which is 2, equals the argument of log, which is x times x minus 3. It is a common mistake to set x equal to 0 and x equals 3 because this is not 0. We can only set the factor equal to 0 if we can zero it out, but 2 squared is not 0, so we have to rewrite this equation. But first, this is 4 equals x squared minus 3x. To solve the equation, we usually zero it out by moving every term to one side and set one term equal to 0. So we subtract 4 from both sides of the equation. The right-hand side is now x squared minus 3x minus 4. If 0 equals x squared minus 3x minus 4, then we can rewrite this as x squared minus 3x minus 4 equals 0. This is a quadratic equation. There are many ways to solve this. Since we zero it out already, we will try to factor the left-hand side. X minus 4 times x plus 1. Every time we factor a trinomial, make sure we double check it. X times x is x squared. X times 1 is positive 1x. Minus 4 times x is minus 4x. 1x minus 4x is negative 3x. And lastly, negative 4 times 1 is negative 4. FOIL. F-O-I-L. And so, since the right-hand side is 0, we can use this principle of zero product. X equals 4 and x equals negative 1. Now, every time we solve a log equation, these are only the potential solution. There might be extraneous solutions, so we still need to check the answer. We are not done at this point yet with logarithmic equation. How do we check the answer? For each of the x that we found, the first x is x equals 4. We plug this into the given equation. The left-hand side is log base 2, x is now 4, plus log base 2, x is now 4. This is only the left-hand side. This is log base 2 of 4 plus log base 2 of 1. Log base 2 of 4 is log base 2 of 2 squared, and log base 2 of 1 is 0 because log of 1 is always 0. Log base 2 of 2 squared is 2, but this is the right-hand side, so x equals 4 is the solution. It checks out. Next, we check the other solution to see if it is an actual solution. For x equals negative 1, we plug in the left-hand side, which is log base 2 of negative 1, and we can simply stop at this step because we cannot take log of a negative number. Log of a negative number does not make sense. We conclude that x equals negative 1 is an extraneous solution, which is not a working solution. So the only solution for this logarithmic equation is x equals 4.